All right, next up in 12.5, we're going to look at question number 2, which is asking us to solve some various rational equations. And up at the top of the worksheet, I just summarized the key things you want to do to solve a rational equation. And the first thing we'll do is to identify any inputs that must be excluded. So recall from section 12.1, we said that for a rational expression, it's possible to plug in a certain value of the variable and then get a division by 0, which is a problem. It will mean that the expression's not defined there. And so when we're going to solve an equation like one of these you see here, we want to make sure to avoid those values of the variable. Okay, so looking at part A, notice I don't have any variables in my denominators. And so for that reason, I don't have to worry about restricted values. There are no restricted values here. Okay, any value I plug in for x in the left-hand side will not give rise to a division by 0. However, in B, since I have a y down here, if I were to set y equal to 0, then that would amount to a division by 0. So here, our restricted value would be 0. So I'm going to say up here, y cannot be 0. Okay. The next thing we're going to do in solving the equation is to clear fractions. And we can do that using our LCD. So for A, our denominators are 4 and 6. So our LCD is 12. And then what I'm going to do is I'm going to multiply this entire left side by 12. And I'm going to do the same thing over on the right-hand side. And as long as I multiply both sides of the equation by the same value, I'm maintaining equality. So we're all good there. And on the left, I'll go ahead and distribute this 12. All right, and you'll notice this calculation we're about to do here is much like what we saw in question 1, and that's why we warmed up with that. So we have 12 times x over 4. So 12 divided by 4 is 3, and 3 will multiply the x. That's going to be 3x. Then we have 12 times x over 6. 12 divided by 6 is 2, and 2 times x is 2x. And then on the right-hand side, I have 28 times 12, and that's 336. All right, and so now we have a nice fraction-free equation. So I have 5x is equal to 336, and then just go ahead and divide both sides by 5, and you are done. All right, so our solution here would be 336 divided by 5, which if you wrote as a decimal, comes out to be 67.2. All right. Great. All right, let's do that same thing now for B. What is our LCD here? Well, our denominators are 3, 5, and y. So for the LCD, I'm going to need a 15 from the 3 and the 5, and then also a factor of y. So I'll go ahead and multiply this entire left side by 15y, and then this entire right side by 15y. And then on the left side, I'll go ahead and distribute the 15y. And that's going to give us, well, 15y times 2/3. 3 goes into 15 5 times, and 5 times 2 is 10. So that's going to give us a 10y plus 15y times 2/5. Well, 15 goes into, 5 goes into 15 3 times, and 3 times 2 is 6. That'd be 6y. And then on the right-hand side, these y's are going to cancel out here and here, and we'll be left with just that 15. And so now on the left, I have 16y, and that's going to equal 15. So again, dividing to solve for the variable, I'm going to get that y is 15/16. All right. So now let's go ahead and look at parts C and D. So for C, Notice here I have an a minus a 4. Okay, so for my restricted values, what can a not equal? A cannot equal 4, because then I'd get 4 minus 4 if a were 4, and that would be a 0 in the denominator. That's a problem. Okay, what's our LCD here? Well, for the LCD, I only have the one denominator, a minus 4, so that would just be a minus 4. So what we're going to do is multiply this entire left side by that LCD, and then I'm going to multiply this entire right side by that LCD. And so on the left, notice the a minus 4 is going to drop out. It divides out, leaving us with just a 1. That's nice. And then on the right-hand side, when I go ahead and distribute the a minus 4 to this first term, the a minus 4 is going to divide out, and I'm going to be left with just this numerator of 5 minus a. And then I'm going to go ahead and distribute the a minus 4 to the 4, and that's going to give us a 4 times a minus 4. And these are being added to each other. Okay, so now let's go ahead and simplify that right-hand side. I'll open up these parentheses by distributing the 4. So we're looking at 1 is equal to 5 minus a plus 4a minus 16. And now we can go ahead and combine like terms on the right-hand side. So that'd be 3a. And then I have minus 11. All right. So then go ahead and add 11 to both sides. And we will get 12 is equal to 3a. And then finally divide both sides by 3. And it looks like we're going to get that a is equal to 4, right? 12 divided by 3. And you might say, okay, great, we're done. Let's move on. Whoa, wait a minute. What did we say at the very beginning? We said that a could not equal 4, right? Because again, if I set a equal to 4 in this original equation, I'm going to get some divisions by 0. So since a cannot equal 4, what this is saying is that I'm actually going to throw this solution out, right? A equals 4 is a solution to this equation further down the line, but it's not a solution to this original equation. It just can't be. And what's going on there, the reason why this is even possible for this sort of thing to happen, is because in our first step of clearing fractions, since we're getting a equals 4 as sort of our phantom solution, what that really amounts to is multiplying both sides of this equation by 0, and then you're just getting 0 equals 0, and that's not really telling you anything, okay? So this sort of thing can happen. Our punchline here is that this equation, in fact, has no solution. Okay? Because the only candidate for a solution would have been 4, but by that restriction from the very beginning, we know that that will not actually serve as a solution. So yeah, there's just no values of the variable a that will actually make this equation true, is what we're saying. All right, and then let's look at D. It's pretty similar. So what's our restricted value here? Well, now b cannot equal 3. Otherwise, again, we'd have some division by 0. For our LCD, well, we only have the denominator b minus 3 show up, so that is the LCD. So just like in the last one, we'll go ahead and multiply both sides of our equation by this LCD. And then I'm going to go ahead and distribute on the left side. So when I distribute here, the b minus 3's will cancel, and I'll be left with just a 1. Then I'm going to distribute the b minus 3 to this 3, and that's going to give us a minus 3 times b minus 3. Now on the right, notice the b minus the 3 divides out, and I'm left with just what's up in the numerator, which is 4 minus b. And now we're rolling. Okay, so let's go ahead. On the left, I'll distribute this minus 3 to open up parentheses. So I'm going to get 1 minus 3b and then plus 9. On the right, I have my 4 minus b still. Now on the left, I'm going to combine the 1 and the 9, so that'd be a 10 minus 3b, and that's equal to 4 minus b. And now what I'm going to do is add 3b to both sides. And I'm going to subtract the 4 from both sides. So I'm moving the variable terms to one side and the constant terms to the other. So on the left, I'm going to get 10 minus 4 is 6. And then that's 0b. And then that's a 0. And then minus b plus 3b, that'd be 2b. Okay, and so then when we go ahead and divide, we're going to get that b is equal to 3. No, unfortunately that's not going to actually work, again, because of this restricted value. If I set b equal to 3 in that original equation, it's going to give rise to those division by zeros. So I actually throw this out, and again, I have no solution. Okay, so this kind of thing can happen. It's just something we have to be on our toes about when it comes to these rational equations. All right, now we'll do the remaining parts of question 2 in the next video. All right, see ya.